So, according to laws of physics, if you can build a spacecraft that goes very close to the speed of light, you can shrink the distance. Actually, the closer you get to the speed of light, the more you can shrink it. And so you can make those 2 million light years. You could traverse across that distance in principle in a minute. However, the downside is that you couldn't come back to tell, if you came back to the Earth at that speed to tell everybody what you'd found, at least 4 million years would have passed on the Earth.
That really is essentially a time machine.
Well, it's a time machine in the sense that we could go arbitrarily far into the future.
What if I told you that time travel into the future might not just be science fiction anymore? A groundbreaking experiment has revealed a bizarre phenomenon that scientists never expected, and it could challenge everything we thought we knew about time itself. Could this be the first real evidence that jumping forward in time is scientifically possible? The results have sparked a heated debate among physicists. Some believe this could rewrite the laws of physics, while others warn it could be too dangerous to explore. But before we dive into that, consider, if traveling into the future is possible, what would it mean for humanity? Stay with us, because what you're about to hear changes everything. For decades, time travel has been confined to science fiction. But what if the key to traveling into the future has been hidden within the laws of physics all along? Recently, Google AI, an advanced system for scientific research, was tasked with analyzing complex simulations of quantum mechanics and time. The goal was to understand how particles behave at microscopic levels, particularly in relation to time. What the AI found was unexpected, an anomaly so strange that some scientists believe it could be the first real clue that time travel into the future is possible. Imagine time as a river that can fork or create whirlpools, allowing time to loop back on itself. Einstein's equations allow for time travel under certain conditions, and this discovery might be the missing piece. At its core, Google's AI is exploring a concept connected to Einstein's theory of relativity, the idea that time isn't constant. Instead, it stretches, bends, and moves differently depending on speed and gravity. We already know that astronauts aboard the International Space Station experience time dilation, where time moves slightly slower for them than for people on Earth. But what Google's AI discovered suggests that this effect might not be limited to extreme speeds or gravity fields. The AI's analysis revealed that under specific quantum conditions, subatomic particles appeared to shift forward in time at rates beyond conventional physics predictions. In simple terms, they seemed to be moving into the future faster than normal, as if bypassing the usual flow of time. If this holds up, it could mean that time travel into the future isn't just a theoretical possibility, it could be happening naturally at the quantum level. But could this phenomenon be scaled up to larger objects or even humans? The scientific community is divided. Some physicists believe this is merely an artifact of the AI's calculations, while others argue that this discovery aligns with existing time dilation theories, taking them to a new level where future time travel could be engineered rather than just experienced passively. The AI didn't just observe this anomaly, it also ran predictions based on its findings, hinting at a potential method for controlling the rate at which time moves forward. Could this be the beginning of a breakthrough in practical time travel technology, or is there something fundamental about time that we still don't understand? The implications are enormous. If Google's AI has truly found a way for particles to jump forward in time, the next step is clear: testing this in the real world. Physicists are discussing ways to replicate this effect in high-energy particle accelerators, like the Large Hadron Collider, which smash particles together at near-light speeds. One proposed method involves trapping quantum particles in an ultra-cold environment and exposing them to extreme magnetic fields, mimicking the conditions in which the AI detected time jumps. If successful, it would be the first controlled experiment where time dilation occurs in an unpredictable quantum way. Some researchers believe that if these time jumps are real, they might be happening all around us right now, we simply haven't had the technology to detect them. If that's true, then time travel into the future may already be a natural process occurring at the quantum level. If we can learn to control it, it raises a huge question: could we one day send larger objects or even humans into the future? It might sound impossible, but just over a century ago, people thought space travel was pure fantasy. However, even if time travel to the future is possible, there are significant challenges. Right now, the effect has only been observed in subatomic particles. Scaling it up to larger objects, atoms, or even humans may require breakthroughs in quantum mechanics, energy manipulation, and possibly even gravity itself. Some scientists argue that even if quantum time travel is real, it may be limited to information, not physical objects. This would mean that while particles can jump forward in time, humans may never be able to follow. Instead, we might be able to send data into the future, potentially unlocking new ways of predicting events before they happen. But what if there's a way around these limits? Some scientists believe that wormholes, theoretical shortcuts through space-time, might provide an answer. Wormholes are a direct prediction of Einstein's general theory of relativity. In theory, they act as tunnels connecting two distant points in space and time. If a stable wormhole could be created, it might allow a traveler to step in at one point in time and emerge at another, potentially far into the future. Some physicists believe that quantum fluctuations, like the ones Google's AI detected, could be the key to stabilizing a wormhole. Normally, a wormhole would collapse too quickly for anything to pass through, but if these quantum time jumps are real, they might be connected to a deeper property of spacetime that allows certain regions to stretch time at an unpredictable rate. However, even if we could open a wormhole, there's no guarantee it would lead to the future. It could just as easily take us to a different location in space or collapse before we could enter it. Still, some scientists believe that wormholes could be engineered using exotic matter, hypothetical particles with negative energy that could keep a wormhole open. If Google's AI has uncovered a real quantum loophole, it might be the first step toward proving that these structures could exist. But before we get ahead of ourselves, we need to answer a critical question: are these time jumps something we can harness, or are they completely beyond our control? So far, the time jumps detected by Google's AI seem to happen under specific conditions, suggesting they aren't just random chaos but instead follow hidden rules we might be able to understand and manipulate. One possibility is using quantum computers to control time at the smallest possible scale. Unlike regular computers, which process information linearly, quantum computers operate using superposition and entanglement, two effects directly related to time manipulation. If scientists can figure out how to trigger controlled time jumps inside a quantum processor, we might be able to send information or even objects into the future at will. Another theory is that gravity plays a key role. If these time jumps are influenced by gravity, placing quantum particles in extreme gravitational environments, like near a black hole, might allow us to amplify and control the effect. If time travel is real, it could explain some of the biggest mysteries in physics, from the strange behavior of neutrinos to the possibility of wormholes. It could also raise questions we're not even ready to answer yet. Now, we want to hear from you. If time travel to the future is possible, how do you think it will change the world? Let us know in the comments.